So this video is on our homework, RFF number 6, again, review for final exam number 6. So on this first problem, we want to solve for y. Very first thing I'm going to do is I'm going to minus the 7, then I'm going to divide by the 4 to get the y minus 1 squared by itself. So I'm going to, again, minus 7, so I get 120. I'm going to divide by 4. So I'm going to get 30. And now at this point, I'm going to square root both sides. So I'm going to get y minus 1 equals plus or minus the square root of 30. And if I could clean up the square root of 30, I would clean it up. And what I mean by that is simplify the radical. And so I'm just going to list squares, because 30 is not a square, but I want to list squares that maybe would go into 30. So let me just list squares. I'm going to write them right down here. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So do any of these numbers go into 30? If any of these numbers did go into 30, then I can simplify this radical 30. Unfortunately, none of these go into 30, so this is going to be as simplified as that can get. Okay. So now my next step is I'm going to add 1, so I'm going to get y is equal to plus or minus 1 plus or minus the square root of 30. And that's your answer. On number 2, okay, this is going to be a polynomial. I need to check the degree. I've got 2. This would be 1, so that's now 3. And another 3, so that's 6. So this is going to be degree 6. And I want to notice it is negative here. So negative means it's going to be flipped from what it normally would. And so when I think of any even degree, I normally think of a parabola. But since it's a negative, I'm going to think of an upside down parabola. So why am I saying that? You're going to be starting and stopping below the x-axis. So I'm going to draw my graph. Don't need to scale my y. I'm going to scale my x. 1, 2, 3, 1, 2, 3. And here I get 0 and it's a double because of the square. I'm going to get negative 3 and it's a single. And I'm going to get 2 and it's a triple. So let me just put those points here. Okay, so 0. And again, this one's a double. Negative 3, this one's a single. And 2, which is a triple. And then I'm going to start below the x-axis because it is an even degree and it's negative. So it's going to be starting below, ending below. So as I come to this one right here, this is a single root. Let me make this a little darker. This is a single root. It's going to go through. This is a double root, so it's going to bounce off. And this is a triple root, so it's going to be like a cubic graph, almost like it's an open up to open down. And that's your graph. On number 3, I'm going to be solving this logarithmic problem. I need to get my logs into a single logarithm right here. I need to make this into a single logarithm. So to do that, I am going to, since this is a plus, that means these things are multiplying, the x and the x minus 2. So I'm going to have log base 4 of x, and I'm going to do this, I'm going to do bracket here, x times x minus 12 equals 3. So I'm going to distribute this. So log base 4 of x squared minus 12x equals 3. And then once I have my log isolated as a single logarithm, I'm now going to rewrite it in exponential form. So this is my base. Your log always is equal to your power. Okay, so this is going to be our power. So I'm going to go 4 to the third is equal to x squared minus 12x. Now 4 to the third is 64. So this is going to be 64 is equal to x squared minus 12x. I'm going to subtract that. So I get x squared minus 12x minus 64. I want to see if this is factorable. So I'm going to try to think of anything that multiplies to a negative 64 and adds to a negative 12. Okay, and I'm thinking negative 16 and positive 4. That is going to multiply to a negative 64, and it also adds to a negative 12. So that means, let me just move this a little bit, I'm going to get x minus 16, x plus 4. So when I solve this, 16 is one possible answer, and negative 4 is another possible answer. Now, before I get excited and start circling these answers, I need to check in my original problem. So let me shrink this out. Oops, wrong direction. Checking my original problem, and I need to see if when I put these in place of my x's here, I cannot take log of a negative. So I want to make sure that I don't get a negative here or here. 16 will not make either of those negatives, so that is going to be an answer. I don't know why I keep grabbing that. So that is going to be an answer. And then when I put negative 4 in, it's going to be negative here. It's also going to be negative here. So this one is not. So 16 is my answer. Got to check for extraneous solutions on that. Okay. Next problem. Number 4. So this one, we are rewriting this in expanded form using properties of logarithms. So I'm going to write this out as separate logarithms. I'm going to have a log for the x, for the y, and for the z. Quick little note here. This is really x to the 4/3 power. The power is your numerator. The root or the index is your denominator. So instead of writing it as the cube root of x to the 4th, I'm going to write it in exponential form. Again, the power is in your numerator, and the radical or the index here, the root we're taking, is our denominator. Now, when I separate these into separate logarithms, anything on top is going to be adding, anything on bottom is going to be minusing. So I'm going to have log base 2 of x to the 4/3 minus, because this is on bottom, log base 2 of y to the 5th minus log base 2 of z to the 8th. Now, all of these exponents, okay, these exponents here, all of these get moved in front. Okay, so I'm going to get 4/3 log base 2 of x minus 5, again, it's going to come in front, log base 2 of y minus, and this 8 is going to come in front, 8 log base 2 of z. And that's your final answer. On number 5, they're asking us to write the equation. If they give you a point to have it go through, that means you're going to have to give me an A. And when it says exact, you're going to have to find an A. We're not going to put this in standard form unless they say, and they're not saying to, so we're going to leave it in factored form. And so I need to pay attention to where it crosses. Crosses here at -1, and it crosses here at 4. Now it crosses here where it bounces off, so this is going to be a double. And then this one, it goes through, but it doesn't go straight through like a line. So this is actually going to be a triple. And so now y is equal to A. And I don't need to worry about my sign. My sign will come when I put in this number and I've solved for A. So don't worry right now if this should be a positive or a negative. We will get that with our problem. So this -1, that came from an x plus 1, because -1 makes that 0. And again, it was a double, so I'm going to write a square. This 4 came from the factor of x minus 4. And since it's cubic looking, it is a triple. I raise it to power 3. And then I'm going to put in this -2, 7. So 7 is equal to a times -2 plus 1 squared times -2 minus 4 cubed. So put that in my calculator. So -2 plus 1 squared times -2 minus 4 cubed gives me -216. So 7 is equal to -216a. So I'm going to get 7 over, or -7 over 216 is my a. So then I'm going to put this in place of my a here for my final equation. I'm just going to write it down here. So I'm going to have y is equal to -7 over 216 times x plus 1 squared, x minus 4 cubed. And that's your answer. On number 6, we're solving a logarithm problem. And we want to make sure we have our log isolated, which it is. I have a single log. And then I'm going to rewrite an exponential form. Remember, whatever your log equals, that's your exponent. So this 5 is my base to the 3rd power is equal to 4x plus 9. Because remember, logs, we're trying to find the power. So this is the power. And now 5 to the 3rd is 125 is equal to 4x plus 9. And now I'm just solving. So I'm going to end up getting 116 is equal to 4x. I'm going to divide by 4. And when I divide by both sides by 4, I get 29 is equal to x. And again, anytime it's a log, you want to make sure you're not taking log of a negative or 0. If I put 29 in here, it's not going to make it a negative. So this is good. On number 7, this is an exponential equation. So I'm going to log both sides, okay? I undo an exponential by logging. So when I take a log of this side, this power is going to move in front. So I'm going to get 2x plus 1. I'm going to put in parentheses, log 3. Again, I log this side, but the power is going to move in front. So I just did that in one step. And I'm going to log the other side. Now I'm going to try to get this 2x plus 1 by itself. So I'm going to divide by log of 3. Then I'm going to be minusing 1. Okay. And then my final step, I'm going to divide by 2. Sorry, this is log of 3. So let me do that in my calculator. I'm going to take log of 7 divided by log of 3. Okay, and I get 1.77. I'm minusing 1 from that. So I get about 0.7712. I'm going to divide by 2, so I divide by 2. And my final answer, x is going to be 0.3, let's say 0.39, 0.3856, so 0.39 about. On number 8, we're trying to expand this. So I'm going to have a log for my q, a log for my p, and a log for my z. And just a little reminder here, this z is being raised to the power 4 thirds. 4 because of the power, 3 because of the index. And I'm going to have a log for q, for p, and for z. Anything on top is going to be with a plus or added, and anything on bottom is going to be a minus or subtracted. So I'm going to have log base 5. And remember, the exponent is going to move in the front. So I'm going to move the 8 in front. So 8 log base 5 of q minus, because this is on bottom, log base 5 of p minus, again, because this is on bottom, and it's a 4/3, so the 4/3 comes in front, 4/3 log base 5 of z, and that's your answer. On number 9, we're going the other direction. We're going to try to write this as a single logarithm. So this 3/5 is the power of a, the 2/3 is the power of b, and the 5 is going to become a power of c. Now, I should be getting a single logarithm. So let me just write log base 2 of something. Okay, and I'm going to put a fraction in it because I see some things are minusing, so those are going to be on bottom, and then this is going to be on top. Now, this, remember, 3/5 is going to be the power of a, but you can write that as the 5th root of a to the 3rd. Again, 3 is the power, 5 is the index. This is a minus, so it's going to be on bottom, and 2/3 is going to be the power of b, which means I'm going to have the cube root of b squared times, and this is also going to be on bottom because of the minus, c to the 5th, and that's your answer. Number 11, write the equation of a circle that has a center at 2, -1. So this is my center, and then it goes through this point. So this point's going to help me find my radius, my r squared. So a general equation of this, x minus h squared plus y minus k squared equals r squared. So this 2, I'm going to have x minus 2 squared. This -1 came from y plus 1 squared equals r squared. And now I am going to put in this 4, this 4 comma 2 for my x and y. So I'm going to have 4 minus 2 squared plus 2 plus 1 squared equals r squared. So I'm going to have 4 minus 2 squared plus 2 plus 1 squared equals 13. So I am going to get x minus h squared plus y minus k squared is equal to 13. And you just put 13 here. Okay, that's what I got when I did that math. So my r squared equals 13. Solving this. So when I'm solving a log equation, I need to get this to be a single log. So this is going to be log base 2 of, and these are going to multiply together. So when I multiply these, okay, and this is what I'm multiplying, x minus 4 times x plus 3. You can do a box, you can do a diamond. You should end up with x squared minus x minus 12. Basically, I am adding these and I get a negative x or -1. I multiply these, I get a -12. Now I'm going to rewrite in exponential form. So my base is 2. The power is always what my log equals, which is which is 3, is equal to x squared minus x minus 12. So this is an 8. I'm going to minus 8. So I get x squared minus x minus 20. And hopefully this is factorable, and it is. So I want it to multiply -20 and add to -1. That's going to be a -5 and a +4. So I'm going to get x is equal to 5 and x is equal to -4. But again, you have to watch out for extraneous solutions. You need to make sure that when you put any of these in, it's not going to make a negative or 0. So 5 works. -4. -4 makes this negative and it makes this negative. So that one's not going to work. So that's a no. So this one is my answer. And last one, number 12. Okay. So on number 12, they are asking us to solve for the x and y intercepts. So to solve for, so if I put in 0 for x, okay, put 0 in for x, you'll notice that the letter I have left is y. So I'm finding my y-intercept. So I'm going to get negative 9y equals 10. So y equals negative 10/9. That's going to be my y-intercept. Now, when I put 0 in for my y, so I get 5x minus 9 times 0 equals 10. You'll notice I'm going to only have an x left, so I'm going to solve my x-intercept. So I get 5x is equal to 10, so x is equal to 2. So I got 2, and then for my y-intercept, negative 10/9. And that's the end of this video.